Number 6 is Anthony. Okay, same deal. 3 minutes. 3, 2, 1, go.
Gravity is the force that we've known about for the longest, and yet still understand the least. Our best modern understanding comes from Einstein. He said that space and time together form a single continuous geometry called space-time, and that the distortions of this geometry caused by matter are what cause gravity as we know it. This is a very elegant, very beautiful theory, but it's incomplete. It doesn't tell us what happens at the centre of a black hole. It doesn't tell us what happens at the start of the universe. It's fundamentally inadequate for studying physics at ultra-short length scales. By short, I really mean short. Now, when you see this through the eyes of a high-energy physicist, this is the holy grail. This is the deep end. This is potentially the theory of everything that takes over at these ultra-short length scales. So how does high-energy physics work? Well, it's the simple principle that if you want to understand the fundamental nature of reality, you smack two things together really hard and you see what happens. So the unit of energy we use is the electron volt, and energy is like 1 divided by length. So 10 electron volts gets you inside the atom. 1,000,000 electron volts gets you inside the nucleus. The Large Hadron Collider was built to study about 100 billion electron volts. And that is the energy you need to make a Higgs boson. That's called the electroweak scale. Lots of fascinating things happen there, but I don't have time to talk about that. Grand unification happens 14 orders of magnitude higher up. That is physics we don't know yet, but that is supposedly where particle physics should all be unified into one glorious whole, with the exception of one thing. Gravity is not included there. The fundamental theory of space-time lies a factor of 1,000 higher up, and that's what I study. Now, this is really tricky to get at. We don't actually have the mathematical methods to get there, and that's where I come in. So I developed the methods supposing that space-time is smooth and continuous at all scales, and that the physics does not depend on our choice of coordinates. This seems like a very simple, obvious choice of things, and you would think it would be not very restrictive, but it is. And it's actually very difficult to come up with the physics to make that all consistent and work. So I constructed the maths to describe what is in effect the hot, young universe of high energy. But also, it tells us something about what's happening in the universe right now. This is a strange new effect, that the expansion rate of the universe is accelerating, which is not what you'd expect from an attractive force. That's called dark energy, and that's about 1,000th of an electron volt if you put it on as the energy scale. This ought to have something to do with quantum gravity, and yet the scales are drastically different between dark energy as we think it is, and quantum gravity as we think that is. And so my PhD studies how to bring these scales together by means of understanding dark energy in the light of quantum gravity, and indeed how that behaves with every scale in between. Thank you very much.